Hi everybody, this is Eugene O'Loughlin, lecturing computing at the National College of Ireland, and welcome to my series of short how-to videos. In this video, we're going to learn how to perform the Mann-Whitney U-test, and we're going to learn how to do this by hand. So before we start, let's take a look at the data that we're going to use in this test. I've got the results of an experiment where I want to compare two treatments, treatment A and treatment B. And these are scores or ratings for by 6 people for treatment A and ratings by 6 people for treatment B. This tells us that this is an unpaired or independent t-test, as we have two groups being tested once. We have equal sample sizes here. They don't have to be for a Mann-Whitney test, they just happen to be so in this case here. Now normally we might use a student t-test to compare two groups for significant differences, but we cannot use a student's t-test if the data are not normal, as is the case here, or if our sample sizes are too small. So a Mann-Whitney test based on ranks is more appropriate with these data here. So as is a test, let's outline our null and alternative hypothesis. Our null hypothesis here is that there is no difference between the ranks of each treatment. Mann-Whitney, as I say, is a rank-based test. And our alternate or research hypothesis is that there is a difference between the ranks of each treatment. So in other words, I'm saying in my null hypothesis is that both the treatments are the same, and in my research alternative hypothesis that the treatments are not the same. We're going to test here at an alpha value of 0.05, and we haven't indicated a direction for our test, so we're going to have a two-tailed test in this case here. So it's a two-tailed, unpaired or independent Mann-Whitney test. So as it is a rank-based test, I need to be able to rank all of these numbers, my 6 values for treatment A and my 6 values for treatment B. So that gives me a total of 12 numbers. So my first task is to rank each of these 12 values from 1 to 12. So I'm going to write out just a series of numbers from 1 to 12 so that I can rank each of my individual values here. So now I'm going to rank all my values from the smallest to the largest value. So I'm going to look for the lowest value to rank it as number 1. I can see I have a 2 on my data, and I also have another 2. So I can rank my first 2 as number 1 and my second 2 as number 2. Now that gives us a tie, so we'll have to come back to that in a few moments. My next highest value is 3. So as I'm going along here, I'm going to tick off each of the values to indicate that I've scored them. Number 4 is my next highest value. And then when I come to the next highest value, which is a 5, so I've got a 5 in treatment A, and I've also got a 5 in treatment B. So I've got to put down 2 5s here, which is another tie. My next highest values is a 6 in treatment A, and there's also a 6 in treatment B. So I'm going to put down the 2 6s here for another tie. Then my next highest value is 7, which I'm going to rank as 9. After that, I've got an 8, which I'm going to rank as 10. I've got a 9, ranked as 11, and finally I have a value of 10, which is my highest value, ranked at 12 in this case here. Now before we do any calculations, we have to check for ties, and yes, we have some ties here. We have 2 2s, we have 2 5s, and we have 2 6s. So we need to be able to rank those. We can't use a ranking of 1 and 2 here because we don't know which 2 it is. Okay, so for example, where we have 2 values of 5, 1 is in treatment A and 1 is in treatment B, so we need to rank those equally. So the way to do that is we just take the average of the rankings for, if we have 2 values, just add the 2 values together and divide by 2. So 1 plus 2 is 3, divided by 2 is 1.5. So my new rankings here are 1.5. Go down to my 2 5s, which are ranked 5 and 6. So 5 plus 6 is 11, divided by 2 is 5.5. My final rankings here, take the rankings 7 and 8 and add them together and divide by 2. So 7 and 8 is 15. So to divide that by 2 gives us rankings here of 7.5. So that's how we deal with ties. So now we can see in our data, for example, here we have nothing ranking as ranking number 1, and we have nothing ranking as ranking number 2, and so on. So now I want to take these rankings here, which I've just worked out, and put them beside each of the scores over here on our left-hand side. So for example, in treatment A, the value of 3, we can see over here that ranked as the 3rd highest value. The value of 4 ranked as the 4th highest value. Then I come to a 2, which was ranked as 1.5. Let's put that in there. And I come to 6, which was ranked as 7.5. 2 was ranked at 1.5 again. And 5, as we can see, was ranked at 5.5. Over to treatment B, we can see that 9 was ranked as 11. 7 was ranked as the 9th highest value. 5 was ranked at 5.5. 10 was ranked at 12. 6 was ranked at a 7.5, another one of our ties, and our final value 8 here was ranked as number 10. So now that we have all the rankings here, our next job then is to sum all of these ranks, because we need to get a value for our sum of each of these ranks. So I'm going to add up all the values for the treatment A, and when I add all of these up, I get a value of 23.0. And when I add up all the values for treatment B, I get a value of 55.0. So these are my rank sum for each of the two values. Now I'm ready to actually do the calculation for the U statistic, which is what the Mann-Whitney U test is based on. My U statistic here in the formula, it's equal to my rank sum, and I've just calculated the two rank sums for my two groups, minus n, the number of values in each treatment. So that's, in my case here, it's going to be 6 for each value. So I'm going to have a 6 here and a 6 in here. So let's now work out the U statistic for treatment A. So that's equal to my rank sum value, which is over here calculated 23.0. minus n times n plus 1, so I've got 6 values, so that's 6 times 6 plus 1, which of course is 7. Divide that result of that by 2, and when I work that out, I get a value of 2.0. Next, now work out the U statistic for treatment B, and that's equal to the rank sum, which is 55.0 in this case, minus the n, the number of variables in, or values in treatment B, which is again is 6 times 6 plus 1. Divide that by 2. And when I work out this value here, I get a result of 34.0. So I've got two U statistics, but I can only use one, and in the Mann-Whitney test, the value that you use is the lowest value. So I'm going to use the U statistic for sample A, or treatment A. So my U stat is equal to 2.0. Next, I need to determine a critical value, which helps us accept or reject our null hypothesis. So I'm going to go to a critical values in the Mann-Whitney U test, and this is for two-tailed testing. And it's based on, I need the n1 for the number of values in group 1, that's treatment A in my case, which is 6. And I also need the number of values in group 2, which is treatment B, which is also 6 in this case. So if I just take the row and where the columns meet, so 6 and column 6 and row 6 here, we can see I have values for alpha equal to 0.05 and alpha equal to 0.01, and I'm choosing 0.05, and we can see there that the critical value is 5 for n1 equals 6 and n2 equals 6 at alpha equal to 0.05. So my U critical is 5. So my U crit is equal to 5.0. So in this case then my result is that my U stat is less than my U crit at alpha equal to 0.05. To be statistically significant, our obtained U, value of 2 here, has to be equal to or less than the critical value of 5. So this is different than other tests, don't forget, where the obtained value usually has to be equal to or greater than the critical value. So our U statistic here is less than our U critical, therefore we have found a difference. We can conclude that the difference we have found between the ratings over here for our two treatments is unlikely to have occurred by chance, so it looks as if the two treatments indeed do differ. So our decision here then is that we are going to reject the null hypothesis, that there is no difference between the ranks of each treatment, in favor of the alternate hypothesis that there is a difference between the ranks of each treatment. We have concluded that there is a difference between the two treatments here using the Mann-Whitney U test. So that's how you calculate the Mann-Whitney U statistic. I hope you found this video useful. Thank you for your attention.